Hello everyone, welcome back to GDC classes English. So dear students, as you all know, for the preparation of MRB Pharmacist Tamilnadu, we are having a series that is Master Stroke, and today in this series we are going to have a subject pharmaceutical chemistry, that is one of the most favorable subject, and the topic of today's class will be titrations like volumetric and gravimetric analysis. So we are going to have questions from these topics. So the topic covered in this video will be volumetric analysis, like fundamentals of volumetric analysis, acid-base titrations, non-aqueous titrations, precipitation titration, complexometric titrations, redox titrations, and gravimetric analysis, principle and methods. So let's get to the first question. Here we have, which of the following is used as an indicator in the titration of a strong acid? Look, a strong acid and a weak base. So when we talk about strong acid and weak base titration, strong acid and weak base titrations, we are having options like phenolphthalein, thymol blue, fluorescein, or methyl orange. So when we take strong acid with weak base, we use methyl orange. We use methyl orange as an indicator. Where the right answer will be D, that is methyl orange. So here we are having the explanation of this question. For strong acid, strong base type of indicator, we use any of the indicators. For case of weak acid and strong base, we are having weak acid and strong base, we use phenolphthalein and thymol blue. For the case where we using strong acid and weak bases titrations, we will be having methyl orange and methyl red, and this was the question that we have been asked. Strong acid and weak base titrations, and for the case of weak acid and weak bases, we can use any of the mixed indicators. Okay, so next question we are having, which of the following is a buffer solution? Which will be a buffer solution? So buffer are the solutions that resist change in pH by addition of a small amount of acids or bases. So buffer solution. So buffers are made via, there are two types of buffer. One is acidic buffer and the other one is basic buffer. When we talk about acidic buffers are made, or you can say prepared by having a weak acid and its conjugate salt, and basic buffers are prepared by mixing a weak base with a strong acid with its conjugate base. Okay, so let's have here H2SO4. This is a strong acid, so no, for preparation of buffer we use weak acids or weak bases, so this can't be a buffer solution. Ammonium hydroxide, okay, this is a weak base. Ammonium hydroxide, look, this is a weak base, and let's say this is NH4Cl, ammonium chloride. So ammonium chloride is prepared when we use NH4OH plus HCl, we will be produced NH4Cl, ammonium chloride. So yes, this can be a buffer solution. Now NaCl and NaOH, no, this is not a base, and this is not a base, and this is a strong base, so can't be a buffer solution. HCl, that is a strong acid, and NaOH, this is a neutralization reaction. We will be having acid base titration, thus producing water and salt. So the right answer will be B. B will be the right answer. Buffers, so buffer are compound or mixtures of compounds that are there, that by their presence in the solution resist change in pH under the addition of small quantities of acid or bases. We are having two types of buffers, like acidic buffer and basic buffer. So acidic buffers is a combination of weak acid and its salt with a strong base. Look, weak acid and salt with a strong conjugate base. You can also say strong conjugate base. So we are having examples like CH3COOH, so acetic acid. So this acetic acid is a weak acid, and when we mix NaOH, so we'll be having acetate, sodium acetate. So they are a acidic buffer combination. Here we also having carbonic acid, H3PO4, and formic acid. Same, we are also having here basic buffers. Examples like NH4Cl, NH4OH, ammonia and NH4Cl, NH3 and NH4 whole twice CO3. And the preparation of this MRB Pharmacist, we are also having a free of cost test series that is every day taking place at 6 p.m. So how to join this test series? You simply have to visit GDC Classes app on the Google Play Store. Open the GDC Classes app, click on the batches section on the bottom, on the below of that interface. You will be asked a batch code, enter batch code MRB25, and you will be directed to this free of cost test series. So here are the steps with the graphical representations. First of all, you have to download this GDC Classes application, that is Pharma Aspirant's First Choice. This will be the name appearing at the Google Play Store. You simply have to install this application. Then after login, you will be directed in this kind of interface, and you touch on this batches section at the bottom of the interface of that application. You simply click on this plus icon and you will be asked a batch code. Enter this MRB25 in small letters without any spaces and you are all set. Next question, a solution of known concentration is the definition of a. So if you are having a solution that concentration, its concentration you are being known. So what do you call this kind of solution? It's a buffer solution, a standard solution, neutral solution, or a test solution. So this kind of solution will be termed as a standard solution. This is a standard solution, or you can say the concentration of the solution, if you have been known, then it will come under the standard solution. So B will be the right answer. Standard solution, the word standard means material containing a substance of our interest with a known concentration. By using this standard, we can find out the concentration of that substance in a new material. In acid-base titration at pH 8.2 to 10, which indicator is used? So basically, we are having this, and this shows that the medium is alkaline, or you can say basic. So in case of alkaline or basic medium, what will be indicator used here? So bromocresol blue, methyl orange, methyl red, or phenolphthalein. So if you are talking about alkaline, or you can say basic nature, so you will be using indicator that is phenolphthalein. Phenolphthalein will be used here as an indicator in this kind of titrations. Here we are having different indicators with their pH range. Like if you talk about methyl violet or thymol blue, methyl orange, bromophenol, they all are acidic. They all are acidic cases indicators till the methyl red. Now bromothymol blue, it's a neutral case, and then thymol blue, phenolphthalein, and alizarin, these are cases for the acidic conditions. Okay, acidic conditions, and they are the pH ranges. Now CH3COH and NH3 titrations is an example of. So acetic acid and ammonia titrations is an example of strong acid. Are you looking acetic acid as a strong acid? No, not at all. Acetic acid is a weak acid and ammonia is also a weak base. So this kind of titrations will come under the category of weak bases and weak acid titrations. So no, this is not a case of strong acid, strong base. Weak acid, strong base, no, not at all. Strong acid, not at all. Weak acid and weak base, yes, the D option will be right. D will be the correct answer for this question. D will be the right, since acetic acid is a weak acid and ammonia is also a weak base. So strong acid is strong base like HCl and NaOH. Weak acid, that is acetic acid, or strong base NaOH. Strong acid HCl, let's take HCl. Weak base like ammonia, or you can say ammonium hydroxide. Weak acid, acetic acid. Weak base, ammonia or ammonium hydroxide. EDTA is, so EDTA that is ethylene diamine tetraacetic acid. So it is a tetradentate ligand, hexadentate ligand, octadentate ligand, or pentadentate ligand. So EDTA, that is ethylene diamine tetraacetic acid. Ethylene diamine tetraacetic acid is a hexadentate ligand. Two of its lone pair of nitrogen are participating in the ligand formation chelation, and further the 4 acetate ions can also take part in the reaction. So it will be having a 6 sites for the reaction. So it will be a hexadentate ligand. Hexadentate ligand will be the right answer. Hexadentate ligand it will be. So look, here we are having 2 nitrogens lone pair and 4 acetate ions. So total there will be 6 possible site for the reaction. So it will be a hexadentate ligand. Mordant black second indicator is used in. So mordant black second indicator, complexometric titration, precipitation titration, non-aqueous titration, or acid base titration. So when we talk about mordant black second, it is a complexometric titration. It is a complexometric titration. It will be used during a complexometric titrations where the formation of complex at the end point takes place, and this complex will be having a simply you can say that visible color appearance, and with this color appearance you can simply check the formation, or you can say you can judge that there will be a formation of that particular complex. So indicators used in the complexometric titrations are mordant black 2, areochrome black T, like you can say solochrome black T, murexide, catechol violet, methyl blue, thymol blue, alizarin, sodium alizarin sulfate, and xylenol. These all are cases where these all indicators can be used in the complexometric titrations. Next question we are having, which is an example of protogenic solvent? What do you mean by protogenic solvent? First of all, so protogenic solvents are those kind of solvents where you can simply obtain protons like H plus ions. You can get H plus ion during these kind of reactions, or you can say these kind of solvents. If the protons can be obtained from these kind of solvents, then it will be categorized under the protogenic solvents. So H2SO4, KOH, NaOH and benzene. So benzene can't give you any protons. NaOH and KOH both will be having OH minus ions. So no protons here will be produced. But in case of H2SO4, so H2SO4 will be having H plus and HSO4 minus. So yes, in case of H2SO4 you can get protons. So this H2SO4 will fall under the category of protogenic solvents. Protogenic solvents. So A will be the right answer. A will be the right answer. So aprotic solvents are those solvents where you can't get protons, or you are not having any protons in that particular solvent. Protogenic can produce H plus ions. Protophilic, like okay, it will be a protophilic. Protophilic means it have love for protons. So you can see that these kind of solvents can accept protons. So they are proton acceptors. These are basic nature and can abstract proton. And amphoprotic means both protogenic and protophilic, both kind of properties are present in these kind of solvents. So these particular types of solvent and their nature are important concepts. So you must learn all these. The next question is having the end point of a complexometric titration is shown by means of. So the end point of a complexometric titrations is shows by the means of colorimetry, pH meter, PM indicator or acid base titration. So when we talk about complexometric titrations, there will be some metals that are actually used during these kind of reactions or these kind of titrations. So colorimetry, no, not at all. pH meter is acid base titration and acid base titration, no. The pH or you can say acid base titrations are not going to be used in these kind of titrations. But PM indicator, what do you mean by PM indicator? Potency of metal. PM means potency of metal. So potency of metal indicators are used during the complexometric titrations, and they are actually responsible for their mechanisms, or you can say reactions. So PM, that is potency of metal indicator. The metallochromic indicators used in the complexometric titrations are organic compounds which can form intensely colored complex, and you can see that the complex that are formed during these kind of complexometric titrations are simply, you can identify them by the colors, by their appearance, by their color formation. So yes, this PM indicator are used for this kind of cases. Next question we are having, which titration is known as the neutralization titration, or you can say neutralization reaction. So neutralization titration means when simply we use an acid and a base, it reacts to form acid base reaction, makes a salt and a water. Salt and water. So neutralization reaction is categorized by acid plus base having salt plus water. So acid base titration, diazotization, gravimetry titration or precipitation titration. So we are having acid when reacted with a base, they produces salt plus water. Salt plus water, and this kind of reactions or these kind of titrations are also termed as neutralization titrations, neutralization reaction. So yes, A will be the right answer. A will be the right answer, that is A, that is acid base titrations. Acid base titration. So acid base titration is also termed as neutralization reaction. Acidimetric and alkalinimetric titrations. Redox, that is a titration where reduction of a compound and oxidation of a compound taking place simultaneously. These kind of reactions are known as redox titrations, oxidation reduction reactions. Complexometric titrations, that is metal ion titrations. Precipitation, that is argentometric titrations. Gravimetry titration, that is quantitative analysis, and non-aqueous titration, that is weak acid, weak base titration. So these kind of titrations and their common synonyms that are being used in our pharmaceutical field. And if you are seriously preparing for MRB Pharmacist, you can also visit to these kind of study materials, like we are having Pharmacist examination kit, that is success kit, a theory book and an objective book, where you can simply practice the questions and the theoretical, all the concepts are being compiled on a single book. So yes, you can use these kind of books definitely. And we are also having online test series for MRB Pharmacist, where 200 premium test and 35 mini test are given. So So you can use these kind of test series, and a crash course is also running for the Tamilnadu pharmacist, these MRB pharmacists. So yes, you can also go through these kind of courses. You can simply check these courses inside the GDC classes application. So now moving to the next question, we are having reduction involves in dash oxidation number. So during reduction, what do you see in the oxidation number of a particular atom or metal? So when we talk about reduction or oxidation, so simply oxidation means oxidation is loss of electron. Loss of electron. So loss of electron, that means you will be having an increase in oxidation state. So oxidation will be having loss of electron, while reduction, when we talk about reduction, so reduction will be having gain of electrons. Gain of electron. So when we are gaining electrons, you are simply decreasing the oxidation state of that particular metal. So when we talk about reduction, it involves reduction, that is the decrease in oxidation state. That will be decrease in oxidation state. While when we talk about oxidation, oxidation will be increase in oxidation state. So A will be the right answer for this question. Reduction will be having decrease in oxidation state. So oxidation, that is losing of electrons, increase in oxidation number, while for a given compound losing hydrogen. If you are talking about hydrogen in respect to the hydrogen, so oxidation means increase in number of oxygens or decrease in number of hydrogens. So if you are talking about reduction, so we'll be having gaining of electrons, decrease in oxidation number, and in respect to oxygen and hydrogen, we will be having, if you are having a decrease in oxygen numbers or increase in hydrogen numbers, they all will be a case of reductions. Next question we are having, which indicator are example of internal indicator? Internal indicator, so is it Sudan red, methylene blue, ferroin, or methyl orange? For internal indicator, it is a ferroin. If you talk about ferroin, this is an indicator, that is internal indicator. So indicator types are self indicators, internal indicator, and external indicators. So self indicators, that is potassium permanganate, ferric ions, iodine. Internal indicators, that is ferroin, diphenylamine. And for external indicators, we will be having potassium ferricyanide. Okay. Now next question we are having, number of moles of solute dissolved in 1 liter of solution is called. So number of moles of solute dissolved in 1 liter of a solution. 1 liter of a solution. So don't you think that is the molarity? It's the concentration term, that is molarity. So normality, no. Normality means we are having equivalent mass, equivalent weights. Molarity will be this, like number of moles dissolved in 1 liter of solution. When you talk about molality, it is what do you mean by molality? It is number of moles of solute dissolved in 1 kg. You take solvent in kg, 1 kg of solvent. And formality, we will be having a formula mass. Okay, so formula mass. So right answer will be B, that is molarity will be the right answer for this question. So molarity, that is number of moles of solute dissolved in 1 liter of solution. Molality, we are having moles of solute per kg of solvent, and for the case of normality, we are having gram equivalents present in per liter of solute. When in iodine solution is directly used for the estimation of a reducing agent, the titration is called. Iodine solution is directly used. So when we use directly iodine solution, this kind of reaction, that is iodine is actually reacting. Iodine, you can see that iodine is inside the reaction. This is known as iodometry. You can see that this is a iodometry. But when we use some compounds, or you can say solution where iodide is reduced to form an iodine, this is iodometry. But when we use some of the solutions to produce that iodine, you can simply see that when iodide, we are having iodide ion, and we simply remove the electrons and to produce iodine, this is known as iodometry. Iodometry. So in iodometry, we are having out, that is, look, this iodine is out, iodine is produced, iodine is out, iodine come out of that particular reaction, and in case of iodine, we use iodine. So iodine is put inside, iodine is put inside. So iodine, that is use of iodine, and iodo, that is out, that is appearance of iodine as the reduced product of that iodide ion. So yes, that is here we are asked that iodine solution is directly used, so iodometry will be the right answer, that is B will be the right answer for this question. B will be the right. So in the iodometry, we are having when analyte that is a reducing agent is titrated. So with a standard iodine solution, the method is known as iodemetry, and when an halide that is an oxidizing agent is added to excess iodide to produce iodine. Next question, when iodine solution is directly used for the estimation of a reducing agent, the titration is called. So you are using iodine solution directly inside that particular titration. What do you call such type of titration? Is it iodometry, iodemetry, oxidation titration, or reduction titration? So no, this is not a case of oxidation reduction titrations. It will be either iod or iodo. So in case of iod, we use iodine. So iodine is put it inside as a solvent. You can say that is directly used inside that particular titrations. While in case of iodo, we are having iodine came out of that particular compound. From iodide we get iodine. So iodine actually came out of that particular reaction, while in case of iod we use iodine solution for that particular compound to react with this iodine. So we will be having iod as our compound, that iodine solution when directly used for particular reducing agent titration estimation. So right answer will be B, that is iodemetry. So in case of iodemetry, when an halide that is a reducing agent is directly titrated with the standard iodine solution, this method is known as iodemetry. While when the halide that is an oxidizing agent is added to excessive iodide, that is iodide is converted into iodine and iodine came out of that particular compound as a compound, this is known as iodometry. Next, we are having end point color in Moore's method. So in Moore's method, the end point color will be red color, blue color, yellow color, or black color. So Moore will be having a red color. At the end point of Moore's method, we are having a red color solution, red color appearance. So A will be the right answer. A will be the right answer. In the case of Moore's method, they falls under the category determining the end point by formation of a colored precipitate and is used for the determination of chloride and bromide in a neutral solution. So Moore's method is generally used for the detection, or you can say determination, for chlorides and bromides. Titrant is AgNO3, that is secondary standard solution. So AgNO3 is standardized by primary standard solution of NaCl measured volume. Like NaCl will be having a known concentration. So yes, this will be a measured volume. Adsorption indicator is used in. So adsorption indicator, where you use adsorption indicator, Fajans method, Moore's method, or Voulard's method. So when we talk about adsorption method, it is used in the Fajans method. Adsorption indicator are used in Fajans method titrations. Indicators are adsorbed on the surface of the precipitation at equivalence point, and this adsorption is accompanied by a color change. These indicators are either acid dyes like fluorescein, eosine, etc., or basic dyes, that is rhodamine. Okay. Titrant is AgNO3 and NaCl. Next question, we are having calcium lactate is assayed by. So calcium lactate is assayed by acid-base titrations, complexometric titrations, non-aqueous titrations, and redox titrations. So we are having calcium, it's a metal, calcium. So calcium will be having a complex formation. So this will be using complexometric titrations. So yes, complexometric titrations will be the right answer for these kind of questions. So here we have some compounds like Al2SO4, whole thrice, bismuth subcarbonate, CH2, that is calcium carbonate, calcium chloride, calcium gluconate, calcium lactate. So these all will be having a complexometric titrations cases. With which of the following analytical methods is it possible to have the greatest precisions? Is it a volumetric titration, linear calibration, gravimetric, or spectrophotometer? So for the case of greatest precision, we use gravimetric. Gravimetric titrations are, you can say that these are quantitative methods, and yes, gravimetric titrations are having the greatest precision methods for the titration. So yes, C will be the right answer. Principle of gravimetric analysis is based on the conversion of ion element radical into pure stable form. Or what are the advantages? Advantages are excessive number of inorganic ions are determined by the excellent precision and accuracy with this kind of methods of titration. Precipitation titration or reaction. Precipitation titration reaction is rapid and quantitative. slow and quantitative, while slow and qualitative. So yes, this is a quantitative reaction, it's not a qualitative. So A and D will be the incorrect. It is a rapid and quantitative or slow and quantitative. So yes, it's a rapid reaction and a quantitative reaction. So B will be the right answer. When we talk about precipitation titration reactions, it's a quantitative kind of reactions, quantitative titrations, and they occurs very fast, so they are rapid also. So B will be the right answer. B will be the right answer. So the requirement for a reaction to be useful in titrimetric analysis, we are having the precipitate must be practically insoluble. That's why it came out of that particular solution, or you can say that the end product. The precipitate reactions should be rapid and quantitative. So if you are measuring that precipitate, it should be a quantitative. The quantity must be sufficient for the measurement of that particular compound. The titration's result should not be hampered by adsorption, that is co-precipitation effects. It must be possible to detect the equivalence point during the titrations. Which one is used as indicator for non-aqueous titrations? What is the indicator used for the cases of non-aqueous titrations? Is it a crystal violet, thymol blue, oracid blue, or all of the above? So for the case of non-aqueous titrations, we use all these kind of indicators, that is crystal violet, thymol blue, and oracid blue. All are correct. All are correct. So all of the above will be the right answer. All will be the right answer. Okay, all will be the right answer. So crystal violet, oracid blue, alpha naphthoyl benzene, that is glycyl acetic acid and glycyl acetic acid, while quinolidine red, all will be having these kind of reactions. And in acid base reactions, what will be the different colors of them, color changes, you can see that they are also given in that table. The reaction in which oxidation and reduction takes place at the same time is called. When the reaction and oxidation are occurring in a reaction, these kind of reactions are reduction reactions as well as oxidation reactions. So it will come inside and we will be simply using them as a redox reactions. It will be a redox reaction. So yes, reduction, oxidation, reduction and oxidation reaction. So it will be a redox reaction. Redox reaction. Okay, tell me a method, or you can say a reaction when a same compound like this A compound is having oxidation at the same time, and this A compound is also getting reduced. So in a reaction where 2 moles of A, one of them is being reduced and the other of them is being oxidized. So one of them will be having gain in electron while the other will be having loss of electron. So what do you name this kind of reaction? There is a specific method. What do you name them? Tell me in the comment section. Okay, so redox titration, that is redox titration refers to the laboratory method to determine the analyte concentration by carrying out the redox titration between analyte and the titrant. The redox titrations often need two redox indicators or a potentiometer since it's a electron bearing reactions. Redox titration depends on the oxidation reduction reaction that occurs between analyte and the titrant. A reagent termed as titrant or titrator is prepared by a standard solution of known concentration and volume. Which of a titration is known as the argentometric titrations? So, which type of titrations are also known as argentometric titrations? Is it acid-base titration, diazotization reaction, gravimetric, or precipitation titration? So, when we talk about argentometric titrations, they are also termed as precipitation titration since we use this AgNO3 as our you can say that standard solutions, secondary standard solution, and in the cases of chlorides and bromides. So yes, it will be a precipitation titrations. It is precipitation titrations. Okay, so AgNO3 NaCl reacts with to form AgCl and NaNO3, and this is also known as precipitation titration. Next, we are having potassium chromate is used as an indicator in. Potassium chromate as an indicator. Is it a Fajan method, Morse method, Vollard method, or all of the above? So we use potassium chromate in cases of Morse method. We use them for the Morse method. So B will be the right answer. B will be the right answer. In case of Morse method, this method falls under the category of determining endpoint by a colored complex precipitate and is used for the determination of chlorides and bromides. Now we use potassium chromate. We use potassium dichromate is used as an indicator and it forms reddish brown precipitate. Okay, potassium chromate. Process of formation of a complex chemical species is called redox titration, complexometric titrations, oxidation titrations, or acid-base titration. So we are having complex formations. So in case of complex formation, the titration will be having complexometric type. Complexometric titrations will be the right answer. Okay, so B will be the right answer. B will be the right answer. In the process of formation of complex chemical species by coordination of the groups of atom which are called as ligands to the central ion, which is a metal ion. Chelate, it is a molecular structure where heterocyclic ring is formed by the unshared electrons of a neighboring atoms, and this is how complex formation takes place. Which among the following is the strongest oxidizing agent? Which among the following is the strongest category of oxidizing agents? Okay, so O3, KMnO4, H2O2 and CO2. So if we talk about them, we are having all are given here, compounds are having some of the oxidation properties. So we are being asked the highest oxidizing agent, highest. So in case of highest oxidations, we see that this O3 molecule, this ozone molecule is actually having the highest acidic or you can say that highest oxidizing power, highest oxidizing agent, strongest oxidation. So this O3 will be the right answer. Oxidizing agent is a substance that oxidizes something else. Oxidizing agent give oxygen to another substrate. So the example will be cuprous and O3, but O3, this is somehow you can say that the strongest, highest, or you can say highest oxidizing agent power, oxidizing power. Indicators are used are those which are added from outside, that is they do not exist in the reaction is called. They do not exist in the reaction and they are added from outside of that reaction, outside the reaction. So they are external indicator, internal, both A and B, or self. So no, they are not self, they are not both A and B, they are not internal. Since you simply see that they are being added from outside of that particular reaction, so they will be cases for external indicators. It will be an external indicator. So A will be the right answer. External indicator are those which are added from outside, that is they do not exist in the reaction. Examples like phenobarbital or methyl orange, they are cases for external indicators. All of the following are oxidation except, all of them are oxidation except one of the given options. So gain of oxygen. So when we gain oxygen, it is in case of oxidation, that is oxidation reaction. Loss of proton. Okay, so proton means that is H plus. Loss of proton tends to be a case for acidity, and acidity do not a case, or you can say the acidity is not the case for the oxidation. So this is just a acidity property. So loss of proton is not the case for oxidation. Okay, look at the other options too. Increase in oxidation state. So yes, oxidation, that means loss of electrons. So you will be having increase in oxidation states in, yes, this will be the right answer. Loss of electron. So yes, loss of electron is oxidation reaction. So yes, D is also right. So if there was loss of H plus, that is hydrogen, loss of hydrogen, it will be case for you can say that loss of hydrogen is a case of oxidation. But here we are having loss of proton, it means proton is getting outside, so it will be having negative charge on the substrate. So it is also a case of gain of electrons. So it will be an oxidation, not reduction. It will be a reduction process. So yes, this is not a case for oxidation. B will be the incorrect. So yes, except addition of oxygen, removal of hydrogen, loss or donation of electron in the overall increase in oxidation state. So yes, these are the cases for oxidation reactions. The end point can be detected by in complexometric titrations. End point in case of complexometric titrations are detected by indicators, ligand, metal ions, or none of the above. So for the case of end point, we are having indicators. We use indicators, and this indicator make that particular compound a colored, and thus how we can see that yes, they are having an end point, or you can say that the reaction is being completed after the formation of that particular colored compounds. So A will be the right answer. Indicators are the auxiliary substances that are added from the outside to the analyte solution upon using which the end point can be detected. The end point indicated by the change in the color of that particular analyte solution. Examples like eriochrome black tea, xylenol orange, muroxide, they all are the cases for the indicators. the analyte ion displaces EDTA from the metal and the metal is subsequently titrated with standard EDTA is called. Analyte displaces EDTA from the metal and metal is subsequently titrated with standard EDTA is called. It's a back titration, direct titration, replacement titration or indirect titration. So first we use displace, that is replace the EDTA. First we have displaced, that is we have replaced the EDTA from the metal and metal is subsequently titrated again with that particular EDTA, standard EDTA solution. So once again replaced. So yes, it's the case for the replacement titration. This is a reaction of a replacement titration where we are replacing EDTA by metal ion formation, metal ion. The metal to be analyzed is added to a metal EDTA complex. The analyte ion displaces EDTA from the metal and metal is subsequently titrated with the standard EDTA. This is the case for replacement titrations. Water hardness can be determined by titrating with it. How you measure hardness of a water? Ethylene, diamine, EDTA, mureoxide or none of the above. So for the case of detection of hardness of a particular water solution, water sample, we use EDTA. We use EDTA as our you can say checking object or you can say that determining object. We titrate with the EDTA. We simply titrate it with the EDTA and this is a case for complexometric titrations. Used to detect concentration of metal ion in the solution. Can be used to determine how calcium, magnesium or other mineral is in a food product. Can be used to determine the concentration of certain toxic metals, and water hardness can be determined by titrating it with EDTA. So it's a case for complexometric titration reactions and EDTA is used for checking the hardness of a water sample. So yes, this is how you can see that they are the questions that were given in this kind of topic. You can simply practice them and you can have, I guess that you are having been, I'm sure that you have all answers correctly marked. So we will be meeting you again with some important topics. Thank you all.